In the present video, we will solve the n jobs through k missions sequencing problem. Let's see the problem. Solve the following sequencing problem, giving an optimal solution when passing is not allowed. Here given the 4 jobs A, B, C, D, which is more than the 2 jobs. And similarly, it is given the 4 missions M1, M2, M3, M4. So it is also more than the 2 missions. So given problem is belongs to n jobs through k missions sequencing problem. Let's see the solution. Since the given problem is to be sequenced on 4 missions, so we have to convert this problem into 2 mission problem by following steps. First step is find the minimum processing time on the mission M1 and the last mission MK, and also find the maximum processing time for the missions M2, M3 up to the MK-1, which is the second last mission. So first we have to determine the minimum processing time for the first mission, that is the M1 mission. In the M1 mission, processing times are the 21, 16, 22 and 21. Among these processing times, minimum processing time is the 16. Similarly, we have to find out the minimum processing time for the last mission. So here last mission is the M4 mission. So we have to determine the minimum processing time for the M4 mission. Here processing times are the 29, 15, 14 and 32. Among these all, minimum processing time is the 14. Next we determine the maximum processing time for the second mission, third mission and the second last mission up to the second last mission. Here, so second mission M2 and second last mission is the M3. So have to determine the maximum processing time for the M2 mission and M3 mission. So first I have to determine the maximum processing time for the M2 mission. In the M2 mission, processing times are the 7, 9, 8, 6. Among these, maximum processing time is the 9. Similarly, maximum processing time for the mission M3 mission is, processing times are the 7, 5, 6, 8. Among these all, maximum processing time is the 8. Next we will go for the step 2. Check the following inequality. First one is the minimum processing time for the M1 mission should be greater than or equal to the maximum processing time of the missions M2, M3 up to the MK-1, which is the second last mission. Another inequality is the minimum processing time for the last mission, that is the K mission, should be greater than or equal to the maximum processing times of the M2, M3 up to the MK-1. So here we determine the minimum processing time for the M1, which is the 16, and maximum processing time for the remaining first and last missions, maximum processing time. So among these all, maximum processing time is the 9. So minimum processing time on the M1 mission is the 16. Maximum processing time remaining first and second last mission, remaining missions, maximum processing time is the 9. So condition is 16 is greater than the 9. And second condition is minimum processing time of the last mission. We determine that one, the minimum processing time of the last mission is the 14. So, and maximum processing time of the remaining missions except the first and last missions. So maximum processing time of the remaining missions is the 9. So here condition is 14 is greater than the 9. So next I have to go for the step 3. If any of the inequalities in step 2 are satisfied, this method is applicable and go to next step. So here inequalities are 16 should be greater than or equal to 9. So it is the greater than 9. So here inequality is satisfied. Similarly, second inequality is the 14 is greater than the 9. It should be 14 is greater than or equal to 9. So it is the greater than the 9. So here both inequalities are satisfied. Then we have to go for the next step. Step 4 is, in addition to step 2, processing time for second mission to the second last mission is fixed constant for all the jobs. Then we have to consider the two missions are the M1 and MK. So first mission and the last mission we have to consider two missions. So first we have to check the processing time for the second mission and the third mission for the all the jobs. So first we have to determine the processing time for the job A on the mission 2 and mission 3. So for the job A on mission 2 is the 7 and mission 3 also 7. So 7 plus 7, 14. For the mission B, processing time on second mission is the 9 and third mission is the 5. So 9 plus 5, which is equal to the 14. Next for the job C, processing time on the second mission is 8 and third mission is the 6. So 8 plus 6, which is equal to 14. Similarly for the last job, that is the job D, processing time is the 6 on the mission 2 and 8 on the mission 3. So 6 plus 8, which is equal to the 14. So here observe, for all the jobs, so processing time on mission 2 and mission 3 is the fixed constant, which is equal to the 14. So we have to consider the two missions, that is the M1 and MK, which is the first and last missions. Here last mission is the M4. So we have two missions, M1 and M4, in the order of M1, M4. Next we find the sequencing of the jobs based on the missions M1 and M4. So write down the missions M1 and M4 along with the processing time of the all the missions. So next we have to draw the optimal sequence table. Size of this table is equal to the number of jobs. So cells in the table, which is equal to the 4. And one more thing you have to remember. If the jobs are fill on the mission 1 means we have to place this job from the left side of the table. And if the jobs are fill on the mission 4 means we have to place the jobs from the right hand side of the table. So next we have to observe the minimum processing time. So here minimum processing time is the 14. So 14 is the minimum processing time among all the processing times, which is related to job C on mission 4. So we have to allocate the job C on rightmost vacant cell. So we have to place the job C rightmost vacant cell. Then we have to delete the job C column. So next we have to observe the minimum processing time among all the processing times. So here 15 is the minimum processing time among all the processing times, which is related to the job B on mission 4. So we have to allocate the job B on right vacant cell next to the job C. So here job B also on the mission 4. So have to place this job B from the left hand side, that is the next to the job B, job C. So next to the job C, we have to place the job B from the right hand side. Then we have to delete the job B column. So next to minimum processing time is the 21. which is related to the job D on machine 1. So we have to allocate the job D on leftmost vacant cell. So in the leftmost vacant cell, you have to fill the job D. So next to minimum processing time is the 24, which is related to the job A on machine 1. So have to allocate the job A on right vacant cell next to the job D. So next we have to remove the job A column also. So we got the sequencing order. Next we calculate the total completion time for the jobs. In this regard, first we have to draw the tabular column. First column is the job. Next column is the machine 1 in time out time. Next column is the machine 2 in time out time. Next column machine 3 in time out time. Next machine 4 in time and out time, and last column is the total completion time for the respected jobs. So in the job column, we have to fill the jobs in the optimal sequence order. So that optimal sequence order is the DABC. So first job D has to be passed to the machine 1. So it is the first job and the first machine. So in time is the 0 and out time is the in time plus processing time. So in time is the 0 and processing time is the 21. So out time for the job D on machine 1 is 0 plus 21, which is equal to the 21. So after the 21 hours, job D has to be moved to machine 2. So in time for the job D on machine 2 is the 21 and out time is the 21 plus processing time is the 6. So 21 plus 6, which is equal to the 27. Next, job D will be moved after the 27 hours on the machine 3. So in time for the job D on machine 3 is the 27 and out time is the processing time plus in time. So 8 plus 27, which is equal to the 35. Similarly, in time for the job D on machine 4 is the 35 and out time is the 35 plus 32, which is equal to the 67. So total completion time for the job D is the 67. Next we calculate the total completion time for the job A. So first job A has to be moved on the machine 1, but machine 1 is engaged up to the 21 hours with the job D. So job A can be moved on machine 1 after 21 hours only. So in time for the job A on machine 1 is the 21 and out time is the in time plus processing time. So 21 plus 24, which is equal to the 45. So after 45 hours, job A is free. Here mission 2 also after 27 hours only it's free. So among these two, maximum is the 45. And the concept is, so mission 2 is free after the 27 hours, but job A is engaged up to the 45 hours with the mission 1. So after the 45 hours only, job A will be engaged for the mission 2. So in time for the job A on mission 2 is the 45 and out time is the 45 plus 7, which is equal to the 52. So next, job A has to be moved to the mission 3. Mission 3 is after the 35 hours free, but job A is up to the 52 hours is engaged with the mission 2. So after the 52 hours only it will be moved on mission 3. So in time for the mission 3 for job A is the 52 and out time is the 52 plus 7, which is equal to the 59. So after the 59 hours, job A will be free then it should be engaged with the machine 4. But machine 4 is busy up to the 67 hours with the job D. So after the 67 hours only machine 4 will be free. So in time for the job A on machine 4 is the 67. So among these two, so highest value you have to enter. So 67 is the highest value. And the processing time is the 29. So 67 plus 29 which is equal to the 96, and completion time for the job A is the 96. So next for the job B. So job B has to be moved on the machine 1 up to the 45 hours. Machine 1 is engaged with the job A. So after 45 hours only it will be free. So job B is move on machine 1 after the 45 hours. So in time for the job B on machine 1 is 45, and the processing time is the 16. So out time is the 45 plus 16 which is equal to the 61. So after the 61 hours only job B will be moved to the next machine. Here job machine 2 is free after the 52 hours, but job B is engaged up to the 61 hours on the machine 1. So after the 61 hours only it will be engaged with the machine 2. So in time for the job B on machine 2 is the 61, and out time is the 61 plus 9 which is equal to the 70. So next job B has to be moved to the machine 3. Machine 3 is free after the 59 hours, but machine B is engaging with the, so job B is engaging with the machine 2 up to the 70 hours. So after 70 hours only job B will be moved on machine 3. So in time for the job B on machine 3 is 70, and the processing time is the 5. So 70 plus 5 which is equal to the 75. And next after the 75 hours job B is the free. It should be moved to the machine 4, but machine 4 is engaging up to the 96 hours with the job A. So after the 96 hours only job B will be moved on machine 4. So in time for the job B on machine 4 is the 96, and the processing time is the 15. So 96 plus 15 which is equal to the, so 111. So completion time for the job B is the 111 hours. So next we have to calculate the for the job C. So after the 61 hours only job C will be moved on machine 1, and the processing time is the 22. So 61 plus 22 which is equal to the 83 is the out time. So after the 83 hours job C is the free. It can be moved to the machine 2. So here machine 2 is also free after the 70 hours only. Then in time for the job C on machine 2 is the 83, and the processing time is the 8. So 83 plus 8 which is equal to the 91 is the out time. So next job C has to be moved on the machine 3. Machine 3 is free after the 75 hours, but job C is engaged up to the 91 hours with the machine 2. Then after the 91 hours only it will be moved to the machine 3. So in time for the job C on machine 3 is the 91, and the processing time is the 6. So out time is the 91 plus 6 which is equal to the 97. So after the 97 hours job C will be free. It can be engaged with the machine 4, but machine 4 is busy up to the 111 hours with the job B. Then job C will be moved on machine 4 after the 111 hours. So in time for the job C on machine 4 is the, so 111, and the processing time is the 14. So out time is the 125. So total completion time for the job C is 125. Next we determine the ideal time for the each mission. So first we observe the first mission. So it is the engaged the job D. Immediately there is no waiting. So 0 to 21 with job D. Then 21 to 45 for the job A. Immediately 45 to 61 it is engaged with the job C. Similarly, immediately it is engaged with the job C. So here there is a no waiting for the jobs, but its completion time is the 83 and total completion time for all the jobs is the 125. So total completion time for the mission 1 is the 125 minus 83, which is equal to the 42. So next we have to look for the mission 2. Initially it is waiting for the job D up to the 21 hours. So initial ideal time for the mission 2 for the job D is 21. Then 21 to 27 it is engaged with the job D. Then so 27 to 45. So here 45 minus 27, so which is equal to the 18 hours is waiting for the job A. Then 45 to 52 it is engaged with the job A. Then again so 61 hours only it is engaged with the job B. So here another waiting time 61 minus 52, which is equal to the 9. Then 61 to 70 it is engaged with the job B. Then again 72 to 83 hours is waiting for the job C. So for the job C, ideal time for the mission 2 is 83 minus 70, which is equal to the 13. Next, so 83 to 91 it is engaged with the job C. So after the 91 hours mission 2 will be free, but total completion time is the 125. So another waiting time is the 125 minus 91, which is equal to the 34. So next we'll look for the mission 3. So initial waiting time for the job D is the 27. So 27 to 35 it is engaged with the job D. Then another waiting here for the job B, that is the 52 minus 35, which is equal to the 17. So next 52 to 59 it is engaged with the job A. So next up to the 70 hours it is the ideal. So ideal time for the job B on mission 3 is the 70 minus 59, which is equal to the 11. Next to 70 to 75 it is engaged with the job B. Next to 75 to 91 hours is waiting for the job C. So mission 3 waiting for the job C is 91 minus 75, which is equal to the 16. So next 91 to 97 it is engaged with the job C. So after the 97 hours it is the free. Then another waiting time is the 125 minus 97, which is equal to 28. Next we have to look for the mission 4. So initial waiting time is the 35 for the job D. Next to 35 to 67 it is engaged with the job D. So next to 67 to 96 it is with the job A. 96 to 111 with the job B. 111 to 125 it is engaged with the job C. So here there is no waiting time. So after the 125 hours only it is the free. So total completion time also 125. And final ideal time also no for the mission 4. So total waiting time or ideal time for the ideal time for the mission 1 is 42 hours. Ideal time for the mission 2 is the 95 hours. For the mission 3 is the 99 hours. And for the mission 4 is the 35 hours. This is the solution, and thank you.